Welcome back to Maths with RP. Today we are going to learn how to use the technique of splitting into partial fractions in integration. Look at the following problem. We have integral of dx by x minus 1 into x plus 1 into 4x minus 5. So what we are going to do is, we are going to write the denominator, which is 1 by x minus 1 into x plus 1 into 4x minus 5 as a by x minus 1 plus b by x plus 1 plus c by 4x minus 5. If we split like this, instead of integrating this, we can integrate this, which will be much easier because we know how to integrate 1 by x minus 1. For example, that is log mod x minus 1. So our aim is to find the values of a, b and c. So what I am going to do is, I am going to take the LCM. So this will be 1 by x minus 1 into x plus 1 into 4x minus 5 equal to a into x plus 1 into 4x minus 5. I am taking the LCM as x minus 1 into x plus 1 into 4x minus 5 plus b into x minus 1 into 4x minus 5 plus c into x minus 1 into x plus 1. From this, we get 1 equal to, the denominators are same, so I can equate the numerator. 1 equal to a into x plus 1 into 4x minus 5 plus b into x minus 1 into 4x minus 5 plus c into x minus 1 into x minus 1. Now, this is an identity for which I need to find the values of a, b and c. The simplest method is, since this is an identity, is true for all values of x. So, suppose I put x equal to minus 1. Then what will happen? Two factors will be 0. When I put x as minus 1, this becomes 0 and this also becomes 0. So 1 will be equal to b into x is minus 1, so minus 2, minus 4 minus 5 minus 9. 4 into minus 1 minus 4 is minus 5, so minus 9. So b equal to 1 by 18. Next, what value I can choose? Let me choose x equal to plus 1. When I put x equal to plus 1, this becomes 0, this becomes 0. Only this will be there. So 1 will be equal to, only the first term is there, a into 2. I am putting x is 2, x is 1. So 1 plus 1, 2. 4 minus 5 minus 1. 4 into 1, 4, 4 minus 5 minus 1. So a equal to minus 1 by 2. Next, what is left? I have to find c. So let me put x equal to 4. When will 4x minus 5 become 0? When I put x equal to 5 by 4. So I am going to put x equal to 5 by 4. So the first term becomes 0, the second term becomes 0. So we will be having 1 equal to c into 1 plus 5 by 4, 5 by 4 minus 1. So this is c into 9 by 4. 5 minus 4 is 1. So equal to 9c by 16 or c equal to 16 by 9. X minus 1 is 5 by 4 minus 1, 5 minus 4 by 4, which is 1 by 4. So c into 9 by 4 into 1 by 4, 9 by 16c equal to 1 or c equal to 16 by 9. Now that I have found the values of a, b and c, this first one, integral I, can be written as Instead of this integral, I can rewrite this as a by x minus 1. What is a? Minus half. So minus half dx by x minus 1, b by x plus 1. B is 1 by 18 plus 1 by 18 integral of dx by x plus 1 plus 16 by 9 into what is the integral of dx by 4x minus 5. Now this is, what is the first integral? Half log mod x minus 1 plus 1 by 18 log mod x plus 1. Here, see, the integral of dx by 4x minus 5 can be written, in fact I have 16 by 9 into. It can be written as 16 by 9 divided by 4. Then I will get dx by x minus 5 by 4. So 4 by 9, so this will be plus 4 by 9 log mod x minus 5 by 4 plus constant of integration c. So this is method is called method of splitting it into partial fractions and then integrating, which makes the process of integration much easier. Now look at this problem. So we always have to check the degree of the numerator and denominator. See, we are actually doing the process of division. So it is possible to split in a particular way, in this way that we discussed in the earlier problem, only if the degree of the numerator is less than that of the denominator. Go to the previous problem. What is the degree of the numerator and what is the degree of the denominator? You can clearly see the degree of the numerator is less than the degree of the denominator. Here the degree of the numerator is 2, the degree of the denominator is 3, so it is clearly less. So I can rewrite I as integral of x square plus 6x minus 5 dx by x into, what will I have, x square minus 4, which is x minus 2 into x plus 2. If I take out x, I will be left with x square minus 4. Now x square plus 6x minus 5 by x into x minus 2 into x plus 2 can be written as a by x plus b by x minus 2 plus c by x plus 2. Therefore, x square plus 6x minus 5 equal to a into x square minus 4 plus b into x plus 2 plus c into x x minus 2. Now I have to find the values of a, b and c. So let me first put x equal to minus 2. When you put x equal to minus 2, this becomes 0, this becomes 0. What will be left? Left hand side minus 2 square, which is 4. 6 into minus 2 is minus 12. Minus 5 is equal to, when I put x equal to minus 2, this term gets 0 and this term gets 0. Only this will be there. So c into minus 2 minus 4, which is equal to 8c. This is what? Minus 8 minus 13. 4 minus 12 is minus 8. Minus 8 minus 5 is minus 13 equal to 8c, or c equal to minus 13 by 8. We need also to find the values of a and b. I first took x equal to minus 2. Let me now take x equal to plus 2. When I put x equal to plus 2, what will happen? 2 square, 4 plus 12, 6 into 2, 12, minus 5. When I put x equal to 2, this becomes 0. The last term becomes 0. The second term will be there. So b into 2 into 4, which is 8b. 16 minus 5. So, 12 minus 5, you know, is 7. 7 plus 4, 11, equal to 16 minus 5, which is 11, equal to 8b. Therefore, b equal to 11 by 8. We now still have to find the value of c. Suppose I put x equal to 0. When I put x equal to 0, I'll have minus 5 equal to, okay, minus 4a, minus 4 in a. Now when I put x as 0, this becomes 0, this becomes 0. So a equal to 5 by 4. When I put x as 0, this becomes 0, this becomes 0. So minus 4a. So here these two terms become 0, minus 5 is left. So a equal to 5 by 4. So this integral I is now equivalent to a 5 by 4 integral of dx by x. You are going to use this. Substitute back for b and c. What is b? Plus 11 by 8 integral of dx by x minus 2 plus 5 by, what is c? Minus 13 by 8 integral of dx by x plus 2. Now this is 5 by 4 log mod x plus 11 by 8 log mod x minus 2 minus 13 by 8 log mod x plus 2 plus c. So is it clear how to use partial fractions in integration? Now this is an application problem. We have integral of dx by, so we are going to use some technique, very important problem, competency based problem. I equal to integral of sin x plus sin 2x. I can write it as 2 sin x cos x. This is integral of dx by sin x into 1 plus 2 cos x. Now, if I put cos x as t, then I need sin x in the numerator. So, I am going to multiply and divide by sin x. Then what will I get? Sin x dx by, here I will get sin square x, which I will write it as 1 minus cos square x into 1 plus 2 cos x. So, now put cos x as t. Then minus sin x dx becomes dt. So, I will be equal to minus integral of dt by 1 minus t square into 1 plus 2t. I can bring this minus sign inside and rewrite this as dt by t square minus 1 into 1 plus 2t. Now, how to split this into partial fractions? That is what we are going to see. So, 1 by t square minus 1 into 1 plus 2t can be written as a by t minus 1 plus b by t plus 1 plus c by 2t plus 1. So, when I take LCM, I will get 1 equal to a into t plus 1 into 2t plus 1 plus b into t minus 1 into 2t plus 1 plus c into t plus 1 into t minus 1. So, we need to find the values of a, b and c. So, I am going to substitute. First, let t be equal to 1. When I put t equal to 1, this becomes 0, this becomes 0. So, 1 will be equal to a into t is 1. So, 2, 2 plus 1, 3. So, a is equal to 1 by 6. Next, t equal to minus 1. When I put t equal to minus 1, what will happen? This becomes 0. What will happen to, see, this has got t minus 1. First one has got a into t plus 1 into 2t plus 1. When I put t equal to 1, I'm sorry, these two values would have gotten cancelled. Let me redo this part. When I put t equal to 1, which becomes 0? This becomes 0 and this becomes 0. So 1 equal to a into 2 into 3. So a is 1 by 6. Next, I am going to put t equal to minus 1. When I put t equal to minus 1, this becomes 0, this becomes 0. So I will get 1 equal to b into minus 2. Minus 2 plus 1 is minus 1. Minus 2 plus 1, t is minus 1. So minus 2 plus 1 is minus 1. Therefore, 2b equal to 1 or b equal to half. Okay, next put t equal to 0. When I put t equal to 0, what happens? 1 equal to, when I put t as 0, I will get a is 1 by 6 into 1 into 1 plus b is half into, when I put t as 0, this becomes minus 1 into 1 plus c into minus 1. Therefore, from this you get 1 equal to 1 by 6 minus half minus c. So, therefore, 1 equal to, we take 6 as LCM, 1 minus 3 minus c. So, 1 equal to minus 2 by 6 minus c, or c equal to minus 2 by 6 minus 1, which is minus 3 by 6 minus 2 minus 6 minus 8 by 6 minus 2 by 6 minus, see, 1 equal to minus 2 by 6 minus c. Bring c to this side. Minus 2 by 6 minus 1. So this will be 6 into minus 2 minus 6, which is minus 8. So what will be the value of the integral? Now I will be equal to, integral of a by t minus 1. 1 by 6 into dx, dx. I'm going to substitute back for t. What is t? Cos x. dt by, or first let me write in terms of t and then substitute. dt by t minus 1. What is b? Plus half into integral of dt by t plus 1. What is c? Minus 8 by 6, which is minus 4 by 3 into dt by 2t plus 1. This is 1 by 6 log mod t minus 1 plus 1 by 2 log mod t plus 1 minus 4 by, I'm going to take this 2 outside, so I'll get 4 by 6. 4 by 6 into integral of dt by t plus 1 by 2. So this will be 1 by 6 log mod t minus 1 plus 1 by 2 log mod t plus 1 minus 2 by 3 log mod t plus half. Put t equal to cos x. Get the answer. So today we learned a new technique, that is how to split a given function into partial fractions. What is the first step that we have to do? We have to check whether the degree of the numerator is lesser than that of the denominator. And then we have seen one particular type where the denominator can be factorized into linear factors. Please go through all these problems. We will do further types in the next video. Until next time, it's goodbye.